In this video, we're going to be taking a look at 3.3, finding distances. Like, hey, listen, we've already done this. We've done this in the previous investigation, so this isn't necessarily new. We're just applying it to the idea of the Pythagorean theorem, right? So knowing this will make things a lot easier moving forward. So we did this investigation too. So the first big question that we are trying to answer is, how can you use a Pythagorean theorem to find the distance between any 2 points on a dot grid? How can you use it then to find the endpoints with a line length of 13 units, or the square root of 13 units? And that is the last part that we're going to do, part E. So you will be able to use a lab sheet on this. If you have the lab sheet for 3.3, which I'll pull up here in a bit, you could answer all of your questions from 3.3 on this lab sheet. Just make sure you title it 3.3 Finding Distances. Otherwise, you will need graph paper or dot paper, either one of those. Here's what that lab sheet looks like. And if you look at the first question, A through D, number 1 says copy the points on, we have this here, then draw a right triangle with segment KL. So go ahead and do that with segments KL right there and right there. Draw a right triangle. There's actually 2 different right triangles you can draw, but we only need one of them. So one of the right triangles, if we connect them, we know that that has to be the hypotenuse. And so one right triangle would be right here. And then the other right triangle would be right here. Okay, so let's go ahead and just use this one for funsies. This is our right triangle. You could use the other one because the lengths of the legs are going to be the same, so it doesn't really matter. So there's our right triangle. It says, draw that triangle with segment KL as its hypotenuse. Number 2, find the lengths of the legs of the triangle. So we are trying to figure out, what are those lengths of the legs? Well, look, they are completely vertical and horizontal, so we can just count 1, 2, 3, 4, 5. So we know this is 5. And 1, 2, we know that's 2. And we're going to label them as units. I think this is actually centimeter grid paper. You could label as centimeters if you wanted to. Part C, use the Pythagorean theorem to find the length of segment KL. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. Go ahead and apply the Pythagorean theorem to try to find the missing side length, which is the hypotenuse. Go ahead and pause the video and try that on your own. Okay, so when we set this up, a squared plus b squared equals c squared, right? So that would be then 2 squared plus 5 squared equals c squared. This is 4 plus 25 equals c squared. 4 plus 25 is 29, so 29 equals c squared. Now, that is the area of the square off of the side C. So if we were to draw the square, it looks something like this, right? That's the area of that square. Well, we need to figure out what the side length is. So if we know c squared is 29, then the side length is going to be the square root of that area, which is what we've been talking about. So in this case, I know that then the side length, if c squared represents the area, this represents the area, then the side length is the square root of the area, which is just 29 units. So this is the length of that hypotenuse. That's part 3 of A. And now let's go ahead. I'm going to have you do problems B and C. B says find the distance between M and N by connecting them. So let's use a different color. So M and N right there, you're finding that distance. And then C says find the distance between P and Q. So distance P and Q would be right there. Go ahead and answer B and C and then come back to the video to see how you did. Okay, so for the first one, we are going to go ahead and create a right triangle. Boing. Boing. We're going to find the side lengths because we can count them. So 1, 2, 3, 4. So this is side length 4. 1, 2, 3. This is side length 3. I know that's a right triangle. And I'm trying to figure out what that side length is there. So we're going to do a squared plus b squared equals c squared. So you would have 4 squared. It doesn't matter, 4 squared plus 3 squared or 3 squared plus 4 squared. It does not matter. Well, it does if you put an equal sign. Plus 3 squared is equal to c squared. So this is going to be 16 plus 9 is equal to c squared. 16 plus 9, that's 25, is equal to c squared. So this represents the area. If we were to put that square there, the 25 represents the area of that square. And so in order to find just the side length, we need to go ahead and take the square root of that. So the side length, which is what we're wanting right there, is the square root of 25. Now, on quizzes and tests, I wouldn't expect you to simplify these square roots down any further than what they are unless it's a perfect square. 25 is a perfect square, which is just 5. So C simplifies down to just 5 units. And make sure we label it. Okay, on part C, if you haven't done this already, make sure you pause the video and do this one. But we're finding the distances between P and Q, and the first thing we're going to do is create a right triangle. And we can count 1, 2, 3, 4, 5, 6. 1, 2, 3. And then set up our Pythagorean theorem. We know that when we take the area of one side, which is 3 squared, plus the area of the square of the other side, which is 6 squared, it equals the area of our hypotenuse squared, and that is c squared. So that would be 9 plus 36 is equal to c squared. 9 plus 36 is 46 minus 1, which is 45. And so if that represents the area of that C side that's squared, then the side length, which is just C, is going to be the square root of 45. And so then this, whoops, not C squared, is just the square root of 45. And then we label it units. This is probably centimeter paper, so again, you could label it with centimeters if you wanted to. Now on to part D, it goes all the way back to the beginning of this unit where we're finding driving distances between points. What is the helicopter distance between these locations? So first of all, you need to figure out what is the driving distance, right? You are going from point A to point B, but you have to drive. So you have to follow the roads. You have to follow the grids. So you could either go that way or you could go this way. Whoops, over one more. But go ahead and figure out what the driving distance is, and then figure out what is the distance if I jumped in a helicopter and went directly from -2.3 to 1.8. Go ahead and find those answers, pause the video, and come back. So our driving distance, we have to go east 1, 2, 3 blocks, and then we go north 1, 2, 3, 4, 5. All right, so then our driving distance, that was 8 blocks. So we'll say 8, I don't know. Yeah, we'll say 8 blocks. Use that as a unit of measurement here. So we had to go 8 blocks. Now, our helicopter distance, let's do this in a different color. That's the distance from there to there. Now you notice we have a hypotenuse here because this is a right triangle. So we have our 2 legs and then we want to figure out what that is. So it's going to be 5 squared plus 3 squared. So those two areas, again, that is 3 squared, that area is 5 squared, and we're finding the area of that side squared, which is c squared. And so that's going to be 25 plus 9 is equal to the area of that hypotenuse side squared off. And then 25 plus 9 is 35 minus 1, which is 34. And then to find the side length, we just take the square root of our area, and that gives us our side length. So our side length here is 34, the square root of 34. Now, this is one of those cases where we're going to have to approximate that, right? So if you think about the square root of 34, it's really close to 36, which is a perfect square. And I know that the square root of 36 is equal to 6. So the square root of 34 is going to be about, we'll say 5.8. Okay, it's going to be about 5.8. So I'm going to use this as 5.8 blocks. That's the helicopter distance. Okay, that's our helicopter distance. And then lastly, it says estimate the difference of the two distances. Well, we're estimating because we don't know the exact answer for the square root of 34. We're not using calculators to find that. But we know that the driving distance is 8 blocks. The helicopter distance is approximately 5.8 blocks. And so the difference of those is going to be 2.2 blocks. Okay, so you're saving a total distance of 2.2 by taking the helicopter, but it probably spends you about $10,000 or costs you about $10,000 more. Lastly, on part E, find the coordinates of 2 points that are square root of 13 units apart. Label the points R and S. Explain how you know the distance between the points is square root of 13. So I hope you get started. So we're just going to have 2 points. Here's point R. Here's point S. And I know that the distance between them is the square root of 13. So go ahead and figure out what the legs will have to be. Because figuring out what the legs would have to be will tell you what these coordinates are. You are looking for what these coordinates are on a coordinate plane. All right, and having those legs will help you. So pause the video, try this, and then come back. So let's take a look at this. So I'm going to go ahead and draw my right triangle. All right, so if this is B and this is A is typically the shorter side, okay? I don't know what those are, so I have to figure out what those are. However, I know when I do the Pythagorean theorem, when I square A and square B, that gives me C squared. Okay, now remember, this represents the area of this side. If I know the side length is the square root of 13, then I know the area is that squared, and the square root of 13 squared, it's like taking the square root of 13 times itself, and that's actually 13. All right, so when you square a square root, these are inverses of each other, and so they undo each other. They untie each other in a sense. So anytime you square a square root, they will cancel. So if you have the square root of 84 and you square that, that's equal to just 84. So when we square the square root of 13, we get just 13. So let's write that in there and get rid of all of those. So you have just 13 is equal to b squared plus a squared. So then we have to think to ourselves, well, what two, and then we're going to use perfect squares here, what two perfect squares will add up to 13? And the answer, if you haven't figured this out already, pause it and try to do this on your own. 9 and 4. Okay, so if I know that the area of one side is 9, so for example, here's my square, and I know that this square has an area of 9, then its side length is going to be the square root of that. So its side length is going to be the square root of 9, which is just 3. And if I know my other side has an area of 4, well, the side length is the square root of 4, which is just 2. All right, so those are my side lengths. Now, that is helpful because what we're trying to do is figure out the coordinates. So let's look at this on dot paper. So we know that one side length is 3. So 1, 2, 3. And then go straight up there. 1, 2. Here we have our little triangle. And we're trying to figure out what these coordinates are. Okay. It doesn't matter. So there's an infinite number of correct answers. So I'm just going to draw a coordinate grid like this. And I can find those coordinates. So 1, 2, 1, 2. So we're at 2, 2. And then 1, 2, 3, 4, 5. So this x value is 5. And then it goes up 2. And then this is also going to be 5, but it goes up to 3, 4. All right, so those could be our coordinates, and that would give me, this has a length of square root of 13 with side lengths of, what were they, 3 and 2. Okay, so you could have any coordinates that kind of match this description. You notice the big idea here is the difference between your x values that has a difference of 3. The difference between your y values has a difference of 2. So any coordinates that match that would work. And that'll do it for 3.3, finding distances.